Let's look at a different kind of problem here. So we got back on his bike again, producing 40 newtons of force on his 8 kilogram bike by pedaling. There's a drag force of 10 and a friction force of 20 newtons, but we want to know now what's the acceleration of the bike. So again, first thing we're going to do, we're going to draw a picture. There's Mac on his bike. We have 40 newtons of force. We have an 8 kilogram bike. We have 10 newtons of drag and 20 newtons of friction, right? And we want to know the acceleration. So there's our picture. We've got everything labeled. So now let's draw our free body diagram. There's our bike. Let's put the forces in. So we have 40 newton. Nope. I won't do that. 40 newtons. Let's label the forces. So we have the pedaling force, and then we have a drag force and a friction force. So now we're going to do our sum of the forces. Let's come up here and label that this way is positive so that we can put that in our sum of the forces. So in our sum of the forces, we have our pedaling force in the positive direction plus our drag in the negative direction plus our friction force in the negative direction, and that equals our net force. Okay, so that's going to simplify. We're just going to put our negatives out there. Minus our drag, minus our friction, equals our net force. And that net force is going to equal the mass times the acceleration, right? And that's going to be our net acceleration. Okay, so we can just kind of get rid of that net and just go with our MA. So we have the pedaling force, equals minus the drag force minus the friction force equals the mass times the acceleration. That's the net. So we're looking for this acceleration, right? So we're going to rearrange our equation. So we're going to divide both sides by m. And that says pedaling force minus the drag force minus the friction force, all divided by the mass, equals the net acceleration. So now we can go ahead and solve our equation. So we have a pedaling force of 40 newtons minus a drag force of 10 newtons minus a friction force of 20 newtons, all divided by 8 kilograms. So the net acceleration is 40 minus 10 minus 20, that's 10 newtons, divided by the 8 kilograms, and 10 divided by 8 is 1.25, and if you remember, there's the kilograms and the newtons, so we have meters per second squared. So the kilograms cancel, remember, we have kilograms, meters per second squared here, so the kilograms cancel. That leaves us with our meters per second squared, so it's 1.25 meters per second squared is our acceleration.